All right, same day, same clothes. I don't want to talk too much because I got several things to get into. All right, let's talk about multiplying radicals real quick. First of all, notice that each one of these examples that I have up here, nothing has a variable. If you have something like this is simple enough to actually put in your calculator. All right? So I just want to make sure we understand that we actually can use our calculator to do these, especially if we're using one of these multi-view type calculators like this. Now, real quick, the number in front is called the index. Now, if there isn't a number, it's understood to be a 2. That's why we call all these square roots. But I can have what's called a fourth root or a cubed root or fifth root or whatever. Any other number other than 2 has to be written in there. You cannot multiply, add or subtract different roots, index. So a cube root and a fourth root you can't multiply, or a square root and a fifth root you can't multiply. They have to be the same index or the same root. Hopefully y'all understood that. Y'all were listening to me. Now, this right here actually equals 3 radical 3. Your calculator will tell you that. But how do I know that? Well, this is actually the square root of 9, which is 3. This radical 3 doesn't simplify. So you wouldn't write radical 3, 3. You would write 3 or the whole number in front of the square root. But again, you can put that in your calculator. I can multiply these two, and it stays underneath. 2 times 5 is 10. But that's not your answer. Neither is that your answer. Both of those are incorrect. This is the square root of 10. They both stay underneath the radical. Now, once you get here, if it can simplify some more, again, your calculator knows that it'll do it for you. But 10 doesn't reduce or simplify anymore. Now notice, even though I have coefficients out front, I still have the same index or indices. And so, sure, negative 3 times 2 is negative 6. 6 times 4 is 24. Now again, if you use your calculator, it'll jump straight to the answer, but that's not correct because I can actually simplify that some more. Why? And I ran out of room, didn't think about this. Negative 6 times the square root of 24 is actually 2 square root of 6. The square root of 24 actually reduces down to 2 square root of 6. Therefore, I can actually do some more here. I can't multiply these numbers times the 6 underneath the radical, and that's important. This is the first one that I've gotten to like that. You can't say 3 times 6 or negative 3 times 6 or 2 times 4. Numbers underneath the radical times numbers underneath the radical, and they stay there. But if they can come out, for example, this 2 is outside, so is this negative 6? Yeah, I can go ahead and multiply that and get negative 12 square root of 6, and so that would be my answer to number 3. Now this, just in case you're confused, this is the same thing as if I would have said negative 6 times 2x, and that equals negative 12x. We treat the square root or the radical just like a variable in terms of that being a coefficient and carrying that along in your answer. Now, notice number 4. I got a cubed root times a square root. I can't do it. That's as far as I can go. You got to have the same root before you can multiply. Now, that's important for us to talk about at the beginning, because we're going to have to know that in order to do what I really want to show you. Now, what I really want to get to is how to deal with radicals and things like this. The reason why I'm talking about radicals and stuff is because we really just got through talking about i's, and what's an I? It's the square root of a negative 1. So I need to talk about the square roots, and then we'll talk about the i's, because it do come, and we need to discuss it. But as it relates to this, let's look at these two examples. Notice what's different here. I got fractions. Here's the deal. You never, ever, 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 ever leave radicals in a denominator. It's just illegal in math. You never leave radicals in a denominator, okay? So that's very important. You might write that in your notes. You never leave radicals in your denominator. I was looking to see if I wrote it down, but I'm kind of getting ahead of myself with some of these notes, but I have to talk about it. So here's the issue. There's really nothing you can simplify with 5 over 2 and 3 and stuff like that. But the issue is that you got a radical in a denominator. Notice I have here, use a calculator if there's no variables. And so what I've done is I went ahead and use the calculator. Try to. Oh well. Anyway, so notice I put this one in the calculator. 5 over 2 radical 3, and when I do that, I get 5 square root of 3 over 6. And I'll show you how that happened. And I'll do the same thing with the other one. When I put this one in, look what I got there. Now, we would write 10 minus 5 square root of 3. The calculator always flips it around like that. But how do we get these strange looking answers from the calculator? Again, without variables, the calculator knows what's up. So let's go through this real quick, run through some examples. The same rules apply to simplifying I. We need to know about that as well. Well, let me just go back to these examples. I'm not ready for the I yet. Let's just go back to these examples and let me explain how I did it. All right, this section right here is really important. All this right here, you want to make sure you write that down. All this stuff is important because that's what I'm about to explain. So I'm going to refer back to that. So you need to pause and get that down. All right? Okay, so those notes that you were supposed to write down basically says if there's one term underneath the denominator, that's all one. It's not being separated by a plus or minus. All you got to do, if this is the case, is multiply the numerator and the denominator, or the whole fraction, by your radical. Okay? And you're going to get 5 square roots of 3 on the top. When you multiply those, it's like a 1 in front. 5 times the square root of 3. And then over here, you're going to have 2 times the square root of 3 times the square root of 3. When you multiply a radical by itself, it's just basically going to be 3. You say, what? So this is really 2 times the square root of 9 right here, right? Well, what's the square root of 9? It's really just 3. So what's the shortcut? Whenever you have a double radical, it's just going to be one of them without the radical. Square root of 5 times the square root of 5 is just going to be 5. The square root of 9 times the square root of 9 is just going to be 9. So this right here is 6. And that's how you got the answer that was in the calculator. 2 times 3 is 6. This is called simplifying your radicals. You never leave a square root in the denominator. Okay, what about this? Now, this is what this is talking about here, called a conjugate. If there are 2 terms in the denominator, 2 terms here, okay, a term is anything separated by a plus or minus. If there are 2 terms in the denominator, then multiply the whole fraction by the conjugate. When I say whole fraction, I mean numerator and denominator. Okay, so what's the conjugate? Same terms, but change the middle sign only. So if the same terms, that means I do 2 minus the square root of 3. This is called the conjugate. 2 minus the square root of 3. I multiply the top, the numerator, and the denominator by that. Okay, where did I get that from? The denominator. I got 2 terms, so I take the conjugate. Now, the reason for that is going to happen when I multiply down here. But in my numerator, I'm going to simply get 5 times 2, distributive property, and 5 times negative radical 3 is minus 5 square root of 3. This distributive property. Remember, there's a 1 in front of there. I didn't do 5 times 3 to get square root of 15. Now, here's the part that you got to realize that this is a FOIL, but I'm going to show you the shortcut. Every time you have the same numbers inside your parentheses, signs included, except for the middle sign is different, you don't have to worry about the 2 middle terms. All you have to do is say the first 2 times each other and the last 2 times each other. 2 times 2 is 4. Square root of 3 times negative square root of 3 is minus the square root of 9. You really should do 2 times 2, 2 times 3, and those 2, and those 2, but they cancel out. Just take my word for it. But it has to be the exact same thing, except the 2 signs are different. Now, if you actually remember from factoring the difference of 2 squares, that should make sense to you, because we've seen this type of stuff before, not necessarily with a radical. Now, remember, we don't want any radicals in the denominator, but I still have one. So how do I fix that? Well, thank you for asking. This is actually 4 minus 3. Where did 3 come from? The square root of 9. So what's 4 minus 3? 1. That's the same thing we got in the calculator. So what I just did is called rationalizing the denominator by using what's called a conjugate. The 2 minus the square root of 3 is the conjugate. So if I asked you, what is the conjugate of 5 plus the square root of 6? The conjugate would be 5 minus the square root of 6. If I asked you for the conjugate of negative 10 minus 14 square root of 3, the conjugate would be negative 10 plus 14 square root of 3. Notice that that sign doesn't change. The only sign that changes is the middle sign. If you multiply a number by its conjugate, a denominator by its conjugate, it's going to eliminate. This same thing should happen every time. Once I multiplied the first two and the last two and simplified, there was no radical in the denominator. Now, I know I'm going kind of fast, but you need to slow down and go back and rewind if some of this stuff I just said is not right, because you need to understand how to use a conjugate. All right? Okay, I got 4 minutes, so I'm going to try to get this in, and you guys might need to come to tutoring so we can really hash this out. But the reason why we were doing this is because I really want to show you how to simplify with I. And remember, I is nothing more than square root of negative 1, so it's just like the other problems except for I'm dealing with an I. So how does it work with an I? Well, you multiply your numerator and your denominator just by I if it's a single term. If it's a single term, we just multiply the numerator and the denominator by I. And notice what I get when I do that. That's distributive property for I, basically. And so when I simplify, I get negative 7 plus 3i. Remember, a plus bi form? And 8i squared is really negative 8. Okay, remember, that's negative 1 times 7. That's why this is negative 7. Why did I flip it in the front? Because, again, a plus bi form is what they're looking for. All right? So, that's simple enough. If it's a single term, just multiply the numerator and denominator by I. I don't care what it is. 10i, negative 8i, negative 100i. If it's an I in a denominator, just multiply the numerator and the denominator by I. Simple enough. The problem comes, or the difficulty or the challenge comes when you got two terms. And it's the same as square roots. We're going to use the conjugate of the denominator, not of the numerator, of the denominator. So hopefully you remember, the conjugate is simply changing the middle sign. All right? And so what you end up with is a FOIL on the top and a FOIL on the bottom. But I've already told you what the bottom is going to be and how to do that on the bottom. Multiply the first two and the last two. All right? You don't have to worry about the middle terms. That's not how you FOIL, but we already know the middle terms are going to subtract out. If I have more time, I will show you. Let me go ahead and simplify some more, and then we'll catch up. All right, follow me. Up here is what we did on the last notes. This is just a FOIL. And so if you didn't understand where these numbers come from, you should go back and look at the last set of notes. But that's all I did was a FOIL between those all the way up here. I had to actually FOIL those because these are not like what's in the bottom. The bottom is the same thing, but different signs in the middle. So all I have to do is just multiply the first two and the last two, because I know the two middle terms like this are going to cancel out. Try me on that if you don't believe me. And so everything here is just simplifying. 20 plus 2. Remember, I squared is negative 1, so 4 times negative 1 is negative 4. So when I put those two together, that's where that 6 came from. And that 22 just came down. 4 plus 16. What about the plus 16? Where did that come from? Well, negative 16 times negative 1. Remember, I squared is negative 1. So 4 minus 16 times negative 1 became 4 plus 16, 20. Now, notice how all of these are even. You want to simplify or reduce if you can, so I did. And really, truthfully, when you separate them like this, this is a plus bi form. And so I want to show you this in the notes so you can get this down. This is what I had just a second ago. Same rules as simplifying an I, okay? And so this tells you if there's one term, what to do. If there's two terms, what to do. And write your answers in a plus bi form. It defines a conjugate. And so you want to look at this right here. You probably want to keep this down, but a lot of this is the same exact thing that we talked about when it comes to the square root. Now, I know I'm talking fast. I went over a lot of stuff, but if you go back to each section, if you come to tutoring, you can get some understanding on these. Yes, we're starting to get a little bit complex, but I told you that this semester of Algebra 2 is going to make you a little bit more uncomfortable, especially those of us who try to do as little as possible. Hopefully you understand. See you soon.